fraction, multiplication. When I multiply fractions, I just multiply the numerators, a over b times c over d. Well, that's equal to a times c over b times d. That's it. And because of the way multiplication works, I can also say a over d times c over b, because it's still AC over BD or DB. Multiplication doesn't matter 2 times 3 or 3 times 2. So notice I can change the denominator around pretty much in any way I'd like. If I have negative 7 halves times negative 8, you can think of it as negative 8 over 1 because it helps put things in its position. You don't have to do that, but that's one way to do it. First thing we want to do is we want to know sign rules for multiplication. When the signs are the same, plus times a plus equals a plus, and a minus times a minus is also a plus. And most people don't really understand that, so I'll give you like a really quick example. Let's say you are in an English class. I'm sure you've heard that you should never use a double negative. Think about like an English sentence. If I say, I'm not going to the store, what does that mean?
You aren't going to the store. You're gonna go to the, wait, I don't know.
Yeah, no, okay, let's break it down. I'm not going to the store.
So you are going to the store?
Exactly. I used two negatives next to each other, and what did it become?
A positive?
It became a positive. I'm not going to the store. Means I am going to the store.
Yeah, and
So
then a positive and a negative equals a negative, right?
Yes, as long as the signs are different, they're always going to be negative. When the signs are the same, they're always positive. When the signs are different, they're always negative. I always thought it was really weird that a negative times a negative is a positive until I decided to like think about it myself. Now you can relate it to something that you already know from language. First thing I'm going to do always is I'm going to take care of my signs, because if I take care of my signs last, most of the time we forget. I see that I have two negatives. I'm going to say this is positive. And then, this is very important, simplify before you multiply. Because once I multiply, I'm going to get 7 times 8, which is 56, divided by 2. Now, that's really not a bad one, but sometimes they get very big, and we could have simplified it sooner, and we wouldn't have had to worry about the multiplication. For example, the rules I just told you said 7 times 8 over 2, and I'm just going to really write over 2. I could write over 2 times 1, but it's really just 2. That works. And I can say 8 divided by 2 is 4. It's better to make them smaller first and then multiply. And I already know it's a positive, so I'm just going to write these as positive numbers. That you mean you could do this?
Yeah.
Absolutely. I just did it this way because I want to show you, I want to show all the skills that we're going to learn. But that's not cross multiplying, by the way.
Is it cross dividing or?
No, it's not cross anything. That's what I mean. People use that word for everything. There's only one thing it is for. Cross multiplication is if you have like a fraction equals a fraction.
Okay.
You can cross multiply. That's the only time, but that's why I never teach cross multiplication, and I never will, because I don't like the words, because people do it for everything. That's why it's called cross multiplication. When we get to this section in class, I'll explain how I'd rather you talk about it mathematically so that you don't get confused all the time about what am I crossing? You're not crossing anything. You're just multiplying. You're not cross multiplying. So I have -7/5 times 1/2. What's my sign going to be? That's the first thing I'm going to think, because if you don't think about signs first, many people will forget them.
Your sign would be negative.
Yes. And then is there anything I can cancel? That's the word you want to use, not cross multiply, cancel. Yes.
No.
There's nothing. I would just multiply across the top and multiply across the bottom. And that's it. That's as simple as it gets, because there's nothing I can cancel. Fraction, division. It has the same rules for signs. Same rules for signs as multiplication. Negative divided by a negative, same as negative times negative, and so on. The only difference is we're actually just going to change this into a multiplication problem. And many people have, I think, used this term, so I'm going to use it. Keep, change, flip. What it means is we keep the first fraction the same. We change the division to multiplication, and we flip the second fraction. That's it. Now we multiply. Let's put these like this. What's the sign going to be here?
Positive.
Perfect. Now, is there anything I can simplify?
You can simplify the 6. I mean, you can simplify both of the sides.
Okay, which way should I go first?
Probably the 5. You can divide 5 by 5, and then 25 divided by
That gives
5.
me 1. That gives me 5. I divide both 25 by 5 and 5 by 5, and I got 5 and 1. Perfect. Let me write that intermediate step so it doesn't get confusing. 5/12. Okay, next.
You can divide the 6 by 6 and get 1, and then the 12 by 6 and get 2.
Perfect. I have 1/1, which we know what that equals, hopefully, and then 5/2. Now, isn't that easier than multiplying 6 times 25 over 5 times 12 and then trying to simplify it?
Yes.
Simplify before you multiply, because now I just have 5 halves. Otherwise, it would be a lot more work. Sign fraction multiplication, more complicated. You may not see these in the software that you're using, but it doesn't hurt to know the next level up. So I have 4, and I'm going to put over 1 just for helpful, so that we know what's the numerator, what's the denominator. 7/-3 times -6/-5. Okay, now I want to, if you have negative A/B, that's really the same as A/-B, because the rules for division are the same as multiplication. So if I have a negative divided by a negative, it's still negative. Or if I have a positive divided by a negative, it's still negative. But often we like to see it as a negative fraction. You can just completely take it outside of the fraction. Whatever you like is fine. Get the signs right. But I just want you to know that these are all equal. First of all, we're going to take care of the signs. Let's just take care of the signs in the numerator. We have a negative in the numerator. What do we have in the denominator? We have negative 3 times
Okay, I was gonna say
negative
it's
5.
positive.
Yes. So we know that's going to be a negative divided by a positive. So that means our sign is negative. Can we cancel anything?
We can cancel the 3 and the 6, right?
Perfect. Exactly. So this and this, we're dividing 6 by 3 is 2. 3 by 3 is 1. So now I have 4 times 7 times 2 divided by 5. Well, I think that's all I can do because none of those numbers divide 5, or 5 divides none of those numbers. Now I'm done, and I don't have to worry about simplifying later if I simplify first. It won't creep up on you. Like, it won't be like, oh, now all of a sudden I have to simplify. Not with multiplication or division. With addition and subtraction, it could. I'm going to say this equals 4 times 7 is 28. 28 times 2 is 56 divided by 5. And it's negative. There's my answer. And I get negative 56 divided by 5. See, it doesn't matter where the negative is. I like to take it completely out of the fraction. It would have taken negative 56 over 5. It would have taken 56 over negative 5, but I like to pull it out completely.